Good morning, students. In the last session, we discussed about combined problem, and in this session also we are continued that topic. Here, in the last session, we discussed a combined problem based on the molecular weight determinations. That means they are giving molecular weight and some other further information like IR and spectral data, NMR spectral data, and mass spectral data. So now, again in this video, we can also discuss combined problems based on molecular weight determinations. So here the molecular weight is 168 and the IR data is 3000 centimeter inverse, 1650 centimeters and 2950 centimeter inverse. And the NMR data we have 3 values and mass having 4 values. So based on these spectral information, we can determine the structure of an organic compound. Let us see, here the molecular weight is 168. From this molecular weight we can determine the molecular formula. So the molecular formula can be done by using some information IR and NMR and mass. Here the value IR 3000 centimeter indicates presence of CH section frequency in alkanes, and 1650 centimeter inverse indicates the presence of C double bond C section frequency or in aromatic compounds or in alkyl molecules. And 2950 centimeter inverse indicates the presence of CH section frequency in our organic molecule. So these 3000 centimeter inverse and 2950 centimeter, both the values represent the presence of CH section frequency in alkane molecules, and 1650 centimeter inverse represents the C double bond C section frequency in aromatic or alkyl molecule. So before we going to calculate the molecular formula, we have to get some background information about our structure. So here the molecular weight is 168. Already in the last session, in the last video, we discussed about how can we calculate molecular formula from molecular weight. That is based on 13 rule. So based on 13 rule, we can determine the molecular formula. So for the determination of molecular formula, we have to obtain some information about number of carbons present in our organic molecule and number of hydrogens and number of extra elements present in organic molecule. Here the molecular weight is 168, that is even number. So the even number represents maybe molecule contains even number of nitrogens or zero number of nitrogens. The molecule contains even number of nitrogens or zero nitrogens. Let us if the molecule contains zero number of nitrogens or even number of nitrogens. Now IR. So IR is 3000 centimeter inverse. So the 3000 centimeter inverse indicates already I said that 3000 and 2950 centimeters, both the values represents CH section frequency in alkanes, and 1650 centimeter inverse indicates C double bond C section frequency. So based on IR data, we have some idea about our structure. That means the molecule contains aliphatic or some alkene chain and one aromatic ring. So that is confirmed in the IR data. That is confirmed in the NMR data. So now let us move to NMR data. That is 1.57 delta 6 hydrogen singlet. So that means the 6 hydrogens attached to one carbon and it does not have any number of hydrogens. So then only it produces a singlet. Then only it produces a singlet. So the 6 hydrogens attached to one carbon, so that these 6 hydrogens appears as a singlet in NMR. And now the second NMR data is 3.07 delta 2 hydrogen singlet. So 2 hydrogen singlet means the CH2 group is attached to some other 2 groups and the 2 groups does not having any number of hydrogens. Then only it produces a singlet. So that the CH2 group is present in our organic molecule. Now the third chemical value 7.27 delta 5 hydrogens singlet. So already in the last 4 problems the same value, that means the range of this value indicates the presence of aromatic benzene ring. Here the value 7.27 represents the presence of benzene ring and it is having 5 hydrogens. That represents benzene is a monosubstitute in nature. That means benzene is monosubstituted in nature. So that we have monosubstituted benzene ring and one CH2 and one isopropyl group. So this is the basic background information we obtained from NMR and IR. So now we have to try to determine the molecular formula from 13 rule by using molecular weight 168. So the 13 rule is what is 13 rule? We have to divide 13 with our molecular weight. 168 by 13 means maybe 12 into 13. That means 156. sorry, yeah, 156. So here we have 138, so then 12, so it remains 156, 168 minus 156, 8 plus 4, 12, so 12 by 30. So now we have to write based on this information hydrocarbon formula. That hydrocarbon formula is C12H24, C12H24. So now by observing the NMR data, we have only 6 plus 2, 7 hydrogens, 7 plus 5, that means 12 hydrogen. But in hydrocarbon molecular formula, we have 24 hydrogens, so it gets excess of 12 hydrogens. Now I have just subtract these 12 hydrogens. The molecular weight of 12 hydrogens is 12. And by observing the NMR data, 6 hydrogen singlet represents CH3. CH3 is attached to one carbon. So that means our molecule having isopropyl group. So that we have 1, 2, 3 carbons. And here we have 2 hydrogen singlet that represents CH2 group is present in our organic molecule. That means we have another carbon atom. So by adding these two, we get 4 carbon atoms in our organic molecule. And the final chemical value 7.27 delta 5 hydrogen singlet represents the presence of benzene ring. So in the benzene ring we have 6 carbon atoms. So 6 plus 4 we have 10 carbon atoms. So here we have 12 carbon atoms. Now I subtract those 12 hydrogens from the formula. So now 2 into 12, 24, 24 plus 12 is 36. Sorry, here 6 plus 2, 7, 7 plus 5, sorry, 6 plus 2 is 8, 8 plus 5 is 13. So now the number of hydrogens is 13 and we have 11 remaining molecular weight, and the final remaining molecular weight is 35. So based on the NMR data and the IR data, I am trying to write some molecular formula about 168 molecular weight. So C10H12 and I have molecular weight remains 35. Now in place of 35 we can write 1 chlorine atom. The molecular weight of chlorine is 35. So that the molecular formula of our organic molecule is C10H12 and Cl. C10H12 and Cl. So based on the molecular formula, now we calculate double bond equivalence. So already in the last 2 sessions or 3 sessions, we discussed about the double bond equivalence. So based on the molecular formula and the number of elements or type of element present in the molecular formula, we can determine the double bond equivalence. Here we have an extra element that is halogen, so that we can write the double bond equivalence formula is Cn plus 1 minus Hx plus Xx by 2. So then Cn plus 1 means 10 plus 1 11, 11 minus 12 hydrogens, sorry, 13 hydrogens plus 1 halogen. So 14 by 2, 14 by 2 means 11, sorry, 7, 11 minus 7 means 4. So the double bond equivalence 4 represents the molecule contains at least one aromatic ring. Maybe we consider that double bond equivalence represents the presence of one benzene ring. Already in the last session we discussed about double bond equivalence of benzene ring. So the double bond equivalence of benzene ring is 4 because it contains 3 double bonds and 1 cyclic ring. So here the cyclic ring is also considered as a double bond equivalent. So that the double bond equivalence 4 maybe represents the presence of benzene ring. It is already confirmed in the IR data because the 5 hydrogen singlet represents the one benzene nucleus. So that we have one benzene nucleus. So this is the systematic calculation for the exam point of view. But in the comparative orientation, we just write the structure based on these information. That means we have one monostructure of engineering and CH2, C, CH3, CH3. Just calculate the molecular weights. The molecular weight of monostructure of engineering is 77, and the CH2 group molecular weight is 14, and the molecular weight of isopropyl group is 15 plus 15, 30, 30 plus 12 is 42. So now I can add all these values. 7 plus 4 is 11, 11 plus 2 is 13, 3 plus 1. So 7 plus 2, 9, 9 plus 4 is 13. So I get 133. So actual the given molecular weight is 168. Now I subtract 168 minus 133. Then I get 35. So that then I can write chlorine atom in place of that 35 remaining molecular weight. So this is the usual calculation completed exam orientation. But in the exam point of view, definitely you have to write the 13 rule to determine the molecular formula, and followed by calculation of double bond equivalence, and followed by calculation of information of IR, NMR, and mass spectral data. Then you can get full marks in your examinations. So that is why I am always trying to determine the molecular formula based on 13 rule. So now just we have to write the structure based on the following units. So we have one monosubstrate benzene ring. We have one monosubstrate benzene ring along with isopropyl group, and one CH2 group and one chlorine atom, and it is a monosubstrate benzene. If now just these 4 units are connected to each other, then we can get the final structure. For example, if the benzene ring is directly connected to chlorine atom, then the structure is concluded. That means we remains with isopropyl group and CH2 group. So that I cannot add this, I cannot connectivity with chlorine atom with benzene ring. So now I am trying to connect this isopropyl group. So CH3, CH3, and we have another valency. Now I can attach this carbon atom with the CH2 group, and this CH2 group I have in one valency, and we have remains with one chlorine atom. Just I can add this chlorine. So here this is the final structure for the organic molecule. For example, if you have to try to add CH2, then it is attached to CH3. This is also another possibility based on these units. Then we have remains with one valency, then you can add chlorine. So we have 2 types of possibilities for this moieties. So which structure is correct? So this is confirmed on the basis of spectral data, that means mass spectral data. In mass spectral data, we have one ambiguous value, that is 92. So 92 peak is obtained. For example, if the benzene ring is attached to CH2, so if the bond is given like this, if it is loosed as a radical, so then it is converted into a CH2 plus. So then the ambiguous value of this is 10, and the CH2 is 14, then I can get 91. So if the structure is like this, then the structure of an organic molecule does not satisfy the ambiguous value 92. For example, if the structure is like this, then let us see here in this molecule, it is alpha, it is beta, it is gamma. Then we can cleave, then we can show a McLaughlin rearrangement: CH2, C, CH3, CH3, Cl, CH3. So if it is undergo McLaughlin rearrangement, so already in mass spectrometry we are well known with McLaughlin rearrangement. What is McLaughlin rearrangement? With a molecule having gamma hydrogen, then it is undergo migration from gamma hydrogen to another position. That means aromatic benzene system. Then it loses one simple molecule. Here the hydrogen atom migrates from this CH3 group to this hydrogen. Then already it have one hydrogen, and it is gets another hydrogen and double bond CH2. Now it is undergo atomerization. Then we can get ambiguous is equal to 92. So here the structure satisfies ambiguous is equal to 92. But if we have to apply the same fragmentation in this molecule, then if it is alpha, beta, this carbon is also beta and this is also beta. So then there is no gamma hydrogen. So then this molecule does not undergo McLaughlin rearrangement. So that this molecule does not generate a peak at ambiguous is equal to 92. So this is the most important fragment ion. So based on this fragment ion, we can confirm the structure B is the correct for our organic molecule. Structure B is the correct structure for our organic molecule. So based on this information, so by using this structure, we can produce the remaining MZ values. So let us write remaining fragment ions. So here the structure is benzene. Benzene is fused with CH2, C, CH3, and Cl. So if the molecule loses Cl as a Cl radical, then it produces a peak at MZ is equal to 133. If the molecule loses benzyl radical, then it produces CH3 plus CH3, 30 plus 35, 65, and 12. 65 plus 12 is 77. So we get MZ is equal to 77. So by using other fragmental modes, other fragmentation modes, we can get the other fragment ions or other MZ values. So based on the IR, NMR, and mass spectral data, the final structure of an organic compound is this. Thank you. In this video, again we discuss another problem. Yeah, students, the second problem in this video is molecular weight based problem. Here the molecular weight is 104 and IR is 2500 to 3000 and 1715 centimeter mass. So again we have to follow the same procedure in the as last problem. Here the value IR 2500 centimeter mass to 3000 centimeter mass. So 2500 to 3500 centimeters indicates OH frequency, in carboxylic acids. This is a very important value. So we already discussed in the classroom. So 2500 to 3000 centimeter mass is the most important value. It exhibits a broad band at 2000 to 3500 for carboxylic acid OH stretching frequency, and 1715 centimeter mass indicates the C double bonded O stretching frequency. Usually we said that this 2500 to 3000 centimeter mass is carboxylic acid. Then 1715 centimeter mass is also for C double bond stretching frequency in carboxylic acid. Then we just move to next data, that is NMR. So the NMR data is 1.27 delta, 3 hydrogen triplet and 2 hydrogen quartet and 2 hydrogen singlet and 1 hydrogen singlet. So here we have 4 signals in the NMR, so that the molecular form, so that means molecule having 4 environments of hydrogens. That means molecule having 4 environments of hydrogens. So based on some background information, so we can calculate the molecular formula based on 13 rule. So let us see 1.27 delta, 3 hydrogen triplet. So that this represents 3 hydrogen triplet. That means CH3 is attached to CH2 group. CH3 is attached to CH2 group. Then it gets a triplet because the spin of these 3 hydrogens interact with the spin of the adjacent 2 hydrogens. Then it is appears as a triplet. So that 3 hydrogen triplet means CH3 is connected to CH2 group. And the second chemical value 3.66 delta, 2 hydrogens quadrat. So 2 hydrogens quadrat. How can we get 2 hydrogens quadrat? Again, 2 hydrogens quadrat means CH2 is attached to CH3. We already write one unit, that is CH3 is attached to CH2. Here we have one CH2 group. So for this CH2 group, we get a quadrat. So for these two values, the common unit is CH3, CH2. So these 3 hydrogens appears as a triplet and these 2 hydrogens appears as a quadrat. And the third chemical value, and the third NMR data is 4.13 delta, 2 hydrogens quadrat. So 2 hydrogens quadrat means 2 hydrogen singlet. So 2 hydrogen singlet means CH2 is attached to 2 groups and it does not attach to any number of carbons. It does not attach to 2 atoms and it does not have any number of hydrogens. So then only it produces a singlet. And the third chemical value is 10.9 delta, 1 hydrogen singlet. In the air data, we already said that, we already discussed that we have 1 carboxylic acid. So that 10.9 delta, 1 hydrogen singlet represents the presence of COOH. That means the 10.9 delta value is for hydrogen atom in carboxylic acid. So by observing these NMR data, we have one CH3CH2 skeleton and a CH2 group and COOH group. So just we have to add the molecular weights of these groups. CH3CH2 is nothing but 29 because 15 plus 14 is 29 and CH2 is 14 and the the ambassador value, that means the molecular weight of COOH is 45. By adding all these values, 9 plus 4, so 5 plus 4, 9, 9 plus 9 is 18, so 1, so 4 plus 1, 5, 5 plus 3 is 8. So then the final value is 88, but the chemical shift value, but the molecular weight given is 104. So then just we subtract 104 from 88, then we can get 16. So we remains with 16 molecular weight. So in place of 16, which atom we have to add? So in place of 16, just we have to add one oxygen. That means the molecule having another oxygen atom other than these two oxygens. That means finally the molecule having 3 oxygen atoms. So this oxygen atom may be attached to 2 hydrogens quartet. That means CH2 because the chemical shift value of 2 hydrogens is 3.66 delta. So just based on these units, so we have to determine the molecular formula. Or based on these information, we can directly write the structure of an organic compound. But in a systematic manner or in examination point of view, we just calculate the molecular formula. So the molecular formula is 104 by 13. So 104 by 13 is how many times? So 13 into 8, so 8 into 3, 24, 104. So 104, so that 8 times and it remains 0, 0 by 13. So then the hydrocarbon formula is C8, 8 plus 0, H8. So this is the hydrocarbon formula corresponding to 104. So based on this information, we have 1, 2, 3, 4 carbon atoms, but here we get 8 carbons. So that I just subtract 4 carbon atoms. So 4 carbons means 12 plus 12 into 4, that means 48. So but observing the NMR data 3, 2, 5, 5 plus 3, 8. So that 8 number of hydrogens. According to the IR data and 10.9 delta 1 hydrogen singlet, we get having one carboxylic acid group. That means we have 2 oxygen atoms. So for 48 we have to add 2 oxygens and it remains with another 16. So from chemical shift value 3.66 delta 2 hydrogens quartet, this means we have another oxygen atom. So that in place of the 16 we can also write another oxygen. So finally the molecular formula is C4H8O3. So this is actually systematic manner, but we already get some units based on NMR data. Based on this we can write this structure. So based on NMR data we get one CH3CH2 group and one CH2 group and one carboxylic acid group and one oxygen atom. Just we have to connect all these units. Just I connect all these groups CH3, CH2. If I attach the CH2 to this CH2, then the multiplicity of these two units will be changes, because the what the NMR data given 2 hydrogens quartet. But if I attach CH2 to another CH2, then this CH2 is appears as a sextet and this CH2 is appears as a triplet. But what they give 2 hydrogens quartet and 2 hydrogens singlet. So that means this CH2 is attached to 2 groups and it does not have any number of hydrogens. So then just I replace this CH2 group by oxygen atom and then I write CH2. So then 2 hydrogens appears as a quadrat and this CH2 appears as a singlet. So now we remains with one carboxylic acid group. We have one valency and I just attach or connect the carboxylic acid group to that CH2 group. So this is the final structure of an organic compound. That means, for example, if we have to remember, we have to forget this group. The name of this compound is CH3COH. That means acetic acid. In place of one hydrogen, we have one ethoxy group. So that means alpha ethoxy acetic acid or alpha ethoxy ethanoic acid. So whatever it may be. So we can write both the names. Acetic acid is common name and ethanoic acid is the IUPAC name. So this is the final structure based on given NMR data. So this is about molecular weight 104 problem. Thank you.